Hello everyone, and welcome to the first video from the series about quantitative finance with Python. In this video I've decided to demonstrate how you can use the Yfinance package in order to extract historical information from the Yahoo Finance API. Yfinance is one of the most popular packages for free use, free access to financial data. But before we start, let's go to the Yahoo Finance page and for example, you can search here for different tickers, like let's say that you'd like to access information for Microsoft. And here you can see the closing price of Microsoft, the pre-open pre-market price, and here this left side menu provides different data. Here we can go to historical data and you can see that this is a typical bar data with open, high, low, close and volume data. So you can use daily, weekly or Monday bars, and you can also select the period of information you'd like to analyze. What we are going to do is to extract this kind of information using the Yfinance package and use it for further quantitative analysis. Here is probably the best moment to mention that the Yfinance package is not affiliated, endorsed or vetted by Yahoo Corporation. So let's move to the code now, and of course before we start we should install the package, which could be done following this command Yfinance pip install Yfinance. Because I have it already installed, I'm not going to run this command. But once it's done, the installation is done, you should import Yahoo Finance, Yfinance as YF for example. And let's start with different examples, because this is probably the best way to demonstrate the different features this package provides. Let's first define a ticker name as the Apple ticker, and extract data using the Yfinance download method. Here we pass to this function the ticker name, which is Apple in this case, and the start and ending date point. And I can print the first few rows and the last few rows. You can go also to the data frame, which is stored into this data variable, and you can see close, high, low, open, volume for Apple day by day. So what's important here is that the default value is daily data. It starts in 2022, in 2020, sorry, and it ends in the end of 2024. So let's scroll to the bottom of the data frame, and you can see here that this is the last available data point. Okay, let's move to the next example, but first you can see the valid periods and the valid intervals. So the periods define how much of history you'd like to extract, starting from today, for example 6 months, and what is the bar sizes. So you'd like, for example, 30-minute bar information or 1 hour daily and so on. Let's take a look at an example. If we want to extract using again this download method information for Tesla for 6 months, starting from today and going back 6 months in history, and this data will be daily. Okay, so let's print the first few rows. You can see that it goes day after day after day. Let me open the data frame, Tesla data, open, high, low, open, volume. And again, you can see here that this data is daily for 6 months as defined here. The next example demonstrates how you can define your custom period. Here, again for Tesla, let's download weekly data this time, and you can see that the data is weekly, 1st, 8th, 15th, 22nd, 29th. You can also access intraday data, but you should keep in mind that it's limited to the past 60 days. So let's take a look at an example of 5 days period with 15 minutes bars. Okay, let's expand this, and here 13:30, 13:45, so it's 15 minutes. Let's open the date frame, and you can see that we have 15 minutes bars for the past 5 days. Sometimes you'd like to export simultaneously information for a few tickers. So let's define a tickers list holding information from Microsoft, Google, and Tesla. Okay, and store the downloaded data into this multi-data variable. You can see that when it's extracted here, 3 out of 3 completed. Let's open the data frame, and of course we have now close, close, close for 3 tickers, high, high, high for 3 tickers. And sometimes you will probably prefer to access only the closing prices. So for example, you can access you can extract closing prices for Google, Microsoft, and Tesla. Just one more step is needed to access the multi-data data frame closing price and store them into a new variable. Okay, because for financial analysis, sometimes you would prefer to collect information into a dictionary. Let's take a look at this code. We are going to use the same list of tickers. The dictionary name is closed data, and we need this kind of loop to download again for each ticker historical information and store it into the dictionary in a separate data frame. Let's take a look. This is closing price. So you can see here closed data. Its type is dictionary. The size is 3 for the 3 tickers. And if I open this dictionary, I have a separated data frame for Google, Microsoft, and Tesla holding the closing prices. Okay. The Yfinance package also gives you access to different financial information, and to be honest, I don't really use it for these purposes, but let me quickly show you that these capabilities are available. For example, you can use this info function in order to access the sector. You can also access different financial information, EBITDA, net income. You can also access financial statements. So here you have the balance sheet, net debt, total debt, and so on. Once again, because I don't use Yahoo Finance for this type of data, I'm not going to show you more of this, but feel free to take a look at the documentations page and explore these features in more detail if you're interested in this kind of financials. Okay, so let's move to the next one. Sometimes we want to access only the last date point, and we don't want to extract a longer historical data frame, and we can do this. Let's define here Yfinance ticker. We want to use EPO, and the last data will be history. This is the method, and the period is 1 day. Let me show you. If I print this one, you can see here that we have only 1 row of data. This is because we've provided here the period of 1 day. And I want to access only the closing prices, which is this price right here. And currently the market is closed, so let's take a look here for Apple. Is this really the closing price? Yes, 200.63. Yes, of course, you should round this number if you want to match exactly the one from the Yahoo Finance webpage. Okay, let's move to the most interesting part. Let's calculate Sharpe ratio, which means that we're going to simulate a portfolio of the 3 tickers and extract historical data for 1 year. Let's do that now. First the tickers, next let's store the data here in this multi-data data frame, again using the download method. You're already familiar with this process. Now we can calculate the returns using the closing prices from the multi-data. Let me show you. So we are going to calculate returns based on these prices for each ticker. Okay, the percent change makes this calculation. This is a built-in function. So you can see here that we have returns for each ticker, for each period. And of course, we should remove these NA values. Okay, so now our data frame, yes, the NA values are removed. And the next step will be to calculate portfolio returns. In this case, I'm going to use equal weighted portfolio, which means that the mean return going for each row will be good for us. Portfolio returns, let's take a look here. Now we have this portfolio returns series. You can take a look at the data frame, and again, this is daily data. So the next steps are to find the volatility of this portfolio, and we are going to need a risk-free rate in order to calculate the Sharpe ratio, which is the last step of this portfolio analysis. So let's calculate the volatility using the standard deviation function. Okay, let me take a look at this here. It's 0.17%. Actually, this is 1% and 76. Okay, the next is risk-free rate. Let's say that we're going to use 2% annual risk-free rate, and we should adjust it to be daily because the returns and volatility are daily. And now when we have everything, let's calculate the Sharpe ratio, which is done by this formula. We should use portfolio returns mean and subtract the risk-free rate, the daily one, and divide this by the volatility. Let's take a look at this. Let me print everything. Okay, so this is the performance of this portfolio for the specific year of 2023. Daily return 0.26%, volatility 1.77, Sharpe ratio 0.15, sorry. Okay, and one final thing. Here, usually you want to visualize some information, so let me quickly show you how you can, for example, extract historical data for Tesla for 6 months, daily data, calculate 50 days simple moving averages. So because it's simple, we are using this mean function. Let's run this line, and the last thing is to plot the closing price and the 50-day simple moving averages and provide a title to this plot. Let's see if it works. Yes, perfect. This is just a simple example, of course, but I think this is enough for basic introduction to the Yfinance package. And one more thing, you should go to the documentation page in order to explore in more detail how to use Yfinance package. Once again, it's not affiliated, endorsed, or vetted by Yahoo Corporation. Thanks for watching, and I'll see you in the next video. Bye.
You can support my channel with a one-time payment or membership through Buy Me a Coffee. Subscribing, liking, or sharing also helps grow the channel. Thank you for your support, and thanks for watching.